Okay, good morning to all of you. Today we will perform the experiment determination of ABCD constants on an artificial transmission line. So as you can see that this is the setup of artificial transmission line. I will request to show the whole setup. So this is the basically artificial transmission line. So artificial transmission line consists of, you can say, majorly of inductance and some resistance. So the back part of it we have connections, and the connections have been taken out from this. So this whole panel behaves like a artificial transmission line, and we will take the measurements from the this end. We can see we have ammeter, voltmeter and wattmeter for the measurement of current, voltage and power. Now the artificial transmission line, as you know, is a two-port network. So a two-port network consists of input port as well as the output port. Okay, so we have three objectives. We have to study the construction of artificial transmission line. So this is the artificial transmission line as just shown to you. Now next is to measure the short circuit and open circuit impedances of the line and calculate the ABCD constant. So as you know that the Z parameters, we have Z, Y, H and ABCD parameters. Okay, so the most common parameter which is used for transmission line modeling is ABCD parameter. Now ABCD parameter has a relationship given by this: VS IS is equal to A times VR plus B times IR, C times VR plus D times IR. So that you can say that we have VS and IS at the input side, and we have ABCD parameters at the output side, and we have VR and IR at the receiving end side. Okay, so usually why ABCD parameters are used for transmission lines? It is used for the transmission lines because it connects the sending end voltage and sending end current with the receiving end voltage and receiving end current. So usually the quantities which are known in the case of transmission lines are receiving end voltage and receiving end current, and if both are known and ABCD parameters are known, the sending end voltage and sending end current can be easily calculated. Now other thing is that this is a case of transmission line in which the parameters are there are two types of parameters. One is lumped parameter and other is distributed parameter. So for medium lines, the shunt admittance, generally a pure capacitance, is included. So what do you mean by lump parameters? Lump parameters means all the inductance and capacitance are lumped at one point. Okay, so in this case the KVL and KCL can work. Okay, in the case of distributed parameters, the differential equation needs to be written. Okay, so that is true for the long transmission line, because in the case of long transmission line, this lumped parameters or lumped modeling approach does not give you the correct results, and that's why we need to distribute the parameters. Now first part is to calculate the ABCD parameters. Now another part is for series compensation. Now in what is series compensation? So as you can see, this is our circuit diagram which we will go through. This is the lumped parameter approach which we are following. That means we have lumped the entire resistance, inductance and shunt capacitance at one flow. This is a pi section. You can also take a T section, and these are the measurements that we will take. And once these measurements are there, we can calculate the ABCD parameters. We can have sending end voltage, sending end current and sending end power, and similarly at the receiving end. Now one thing is important to know, that how to calculate these parameters. If you focus here again, VS is equal to A times VR plus B times IR. So you can write down VS is equal to A times VR plus B times IR, and similarly IS is equal to C times VR plus D times IR. So if you open circuit the output parameter, this will go away. IR will become 0. So IR will become 0, so you can calculate A and C. And similarly, if you short circuit the outside parameters, keeping in mind that not heavy current flows in the system, and so this will go 0. If you short circuit, this will go 0, and then you can calculate B and D. Okay, so this is a very simple procedure. Just you have to short circuit and open circuit. Now one thing is important, why you use compensation. Okay, compensation why you use? Now compensation means, so this is the simple, you can say the circuit diagram which you have to follow. This is the wattmeter, this is the ammeter, voltmeter, supply, and we will short circuit and open circuit things at from the sending end as well as the receiving end. Now compensation, why compensation is done? Here we are using the series compensation because compensation is done so that the line reactance gets reduced. Okay, so this is the net inductance. Resistance is small as compared to inductance in transmission line. So if you connect a capacitor here, what will happen? The total inductance of the system will become XL minus XC, and when this total reactance goes down, you can know the expression of power transferred, that is EV by X sin delta. This is the power transferred from one end to another end if the sending end voltage and receiving end voltage and the line reactance is known. Now how to increase this power? This power can be increased if this X can be controlled, and when this X can be controlled, this is basically inductive. And how you can make it less inductive? To put a series capacitance. Okay, so if it will be reduced, the power transfer will increase. This is one of the reasons for doing series compensation. Another reason is to increase the stability of the system. Okay, because series compensation also reduces this. And for example, the primary, there are two types of compensation. One is series, another is shunt. So series compensation is primarily used to increase the steady state power through the transmission line. Shunt compensation, in which the capacitor is connected in the shunt, mostly at the load side, is used to supply the reactive power in the system. Because what happens that most of the time our loads are inductive in nature. So they require lagging VARs from the system, lagging reactive power from the system. So if this, and Q, you know from your load flow studies, is proportional to V. If there is a deficit of Q in the system, the voltage collapse will happen. That means the voltage will go down. Okay, just like this. If the Q keeps on increasing, the voltage will after a certain point collapse. That means the leading VARs, the lagging VARs which are required in the system by the inductive load, because most of our load are inductive, fans, motors, transformers, whatever load you take is highly inductive. Now to compensate that load, you need capacitor banks. Okay, so that capacitor bank can supply those lagging VARs to the system, or you can say the capacitor supplies plus Q to the system. Okay, and basically capacitor is the source of reactive power, inductor is the sink of reactive power. So this balance needs to be happen at every time in the system. So sometimes the heavy inductance, heavy reactive power is required in the transmission line. So one of the techniques is to use the capacitor banks. Okay, other techniques are also there. For example, you can use synchronous motor in overexcited mode. They also supply reactive power. You can use FAC devices, but the simplest solution is to use a capacitor bank which is directly connected to the three-phase transmission line. Okay, so this needs to be done. So this much is the theory. We are going to calculate these ABCD parameters both in the case of compensated as well as uncompensated form. Okay, so you will feel the difference, that which parameter will change when the capacitor is used, and which parameter will not change if the capacitor is not used. So there is two types of experiment going on. One is uncompensated and another is compensated, and in both the case we will calculate the ABCD parameters and see what is the difference. And these ABCD parameters have their own significance also. A denotes something because A denotes Vs by Vr, that is the voltage gain. B denotes impedance, Vs divided by IR. Similarly, C will denote Is by Vr and D will denote Is by R, current gain, voltage gain, impedance and admittance. So basically ABCD parameters give you complete information about the transmission line. And this is practical, because in practically we also know only these things. Okay, suppose once you know ABCD parameters and load side parameters, you can predict the source side parameters. This you cannot do with the H parameters or Z parameters. Okay, because Z parameters, what will happen? V1 V2 will come this side and I1 I2 will come this side. Okay, so you cannot simultaneously in a practical system know Either you will do measurements on load side or you do measurements on source side. This is an experimental setup. So here we can measure both. Okay, but practically we can measure only load side parameters. Okay, because source is very far away and it is connected through the transmission line which you have lumped. Okay, so this much is the theory, and now we will perform the experiment. Close.